Right. Let's start this section by downloading content from the internet using our terminal. We will use two popular and powerful command line tools, curl and wget. Both are great when we are dealing with URLs, but they are slightly different when handling the downloads. What we need now is a download link. So let's grab one for a Linux app image. App images are portable applications that work across major Linux distributions without the need for installation. Let's say we are dual booting Fedora and Windows. For that, we need to make a bootable USB device. We can do that using tools like Rufus or Bpytop. Bpytop comes in various formats, and one of those is an app image. So let's copy its download link and go back to our terminal. We will first download it using wget. The wget command is straightforward. If we add the download link after wget, it just downloads the file to the current directory. Note that it has saved the file using the same name as that of the remote file. If we want to use a custom name, we can add the uppercase O flag. Now let's use curl. If we check the download link, we are actually downloading from GitHub. Curl deals with GitHub links a bit differently. So if we are downloading from a non-GitHub page which doesn't require redirection, we can simply type curl uppercase O flag and then the URL. This downloads a text file from that site with the same name. This is equivalent to wget and then the URL name. However, if we try the same thing on a GitHub link with curl, it creates an empty file. So to download a file from a GitHub link with curl, we should add the uppercase L flag which follows the redirects. So the uppercase O flag in wget and curl is quite the opposite. While using curl, to add a custom name, we have to use the lowercase o flag. This is just an overview of these tools. They have many more functions. Note that since Fedora 40, we have wget 2 as the default version, which supports multi-threading. While we are at it, check out Axel. It's a terminal-based download accelerator. It downloads a file using multiple connections, which can speed things up on slow networks. Right. Let's delete all redundant app images and just keep one. Now, if we list the contents of our current directory, we see that the app image is just like our other text files. It is not an executable file. If you remember, in the first part, we saw that this set of 9 characters represents permissions for the current user, the users group, and others. The app image has only read-write permissions for the current user and no executable permission. If we try to run it, we get a permission denied error. To make it executable, we have to change the permissions. We can do that using the chmod command. Chmod +x and the file name. If we recheck the contents, we can see that the app image is now executable. So +x has given executable permission to all. Now we can run the app image by typing /filename. If we look at the changed permissions, they are in this format. The user has rwx permissions, the users group has rx permissions, and the others also have rx permissions. We can represent these three sets of permissions as 3 digits, 755. That means the user's permission rwx is equivalent to 7 and users group and others permissions rx are equivalent to 515. So chmod 755 and the file name sets the current permissions rwx, rx, rx. Whereas chmod 777 sets all permissions to all users. If we do not want to give any permissions to any of the users, we can set it with chmod 000. But how are these digits attributed? To understand this, we have to look at the binary representation of these permissions and then convert them into the octal system. In the decimal system, we have 10 digits, 0 to 9. Whereas in the binary system, we have 2 digits, 0 and 1. And in the octal system, we have 8 digits, 0 to 7. Now, let's take one set of permissions from the 3 and convert them into the binary system. So, our file has no permissions for any of the users. And if we take the current user's permissions, it is represented by 3 dashes. Converting to binary system is very straightforward. If there is no permission, it is 0 at that position. And if there is a permission, it is represented by 1. So now our binary value for the current user is 0, 0, 0, which is equivalent to 0 in both decimal and octal systems. Now, if we give just the executable permission to the user, we have dash dash x. So in binary notation, it is 0, 0, 1, which is equivalent to 1 in decimal and octal systems. Now to represent 2 in decimal and octal systems, we have the digit 2. But that is not the case in the binary system. We have only zeros and ones. So when we are out of digits in the decimal system, we add an extra position. So after 9, we go back to 0 and add 1 in the tens place to actually represent the next number, that is 10. Similarly, after reaching 99, we add an extra position to make it 100. So we have ones place, tens place and hundreds place. Basically, we are adding the places or positions when we run out of digits. 001 is 0 plus 0 plus 1, 010 is 0 plus 10 plus 0, and 100 is 100 plus 0 plus 0. That's the decimal system. In the octal system, since we have only 8 digits, these positions or places would be 1s, 8s and 64s. So 001 is 0 plus 0 plus 1, that is 1. 010 is 0 plus 8 plus 0, that is 8. 100 is 64 plus 0 plus 0, that is 64. Now when we come back to our binary system, the 3 positions represent 1s, 2s and 4s places. So 000 is 0 plus 0 plus 0, that is 0. 001 is 0 plus 0 plus 1, that is 1. Now since we are out of digits, we have to shift to the next place, which means we are looking at 010, which is 0 plus 2 plus 0, that is 2. So if we convert our 010 to the permissions, it would be dash w dash. Our binary 3, 011 converts to dash wx. If we do all the conversions, we get up to 111, that is full permissions rwx, and it is equivalent to 4 plus 2 plus 1, that is equal to 7, either in the decimal or octal system. Since we need only 0 to 7 digits, we can use the octal system. So 1 digit for 3 permissions of the user. If we add the other 2 sets, we get our 3-digit representations. So we have chmod 777 file name, full permissions to the users. chmod 000 file name, no permissions to any of the users, and all the octal combinations in between. For more information, you can look at the chmod cheat sheet. Right. That's about changing the permissions. How about changing the ownership? If we see the list of contents, all the items are owned by the current user and the users group. We can change the ownership of a file or directory using chown. However, since we are dealing with other users and groups, we need to perform this with root privileges, that is by using sudo. So I currently have 2 users on this system along with the root user. If I want to change the ownership of a file to another user, I can type sudo chown username group name and then the file name. Enter the sudo password and the ownership is changed. Now you don't have permission to use the file. We can also change the ownership to root. Say you have 5 user accounts and want to share the files with only 2 of them, you can create a new group, say shared. add the users to that group. And while changing the ownership of the files, add the new group name instead of the user's group name. You can change the permissions of directories as well. Sudo chown username, group name, directory name. However, the ownership of the directory's contents has not been changed. To do that, we need to add the recursive flag. Well, let me own this back. Next up, let's have a look at archiving and compressing data. You might have come across formats like zip and rar files, which are pretty standard archiving and compression formats. However, there are a lot more formats than these two. Some of these are either just compression formats like gz and bz2, or just archiving formats like tar and iso, while others are both, like zip, rar, 7-zip, dmz and jar. Let's look at zip, tar and gz formats. So we have a directory called split dir. To archive and compress a directory and its contents into the zip format, we can use the zip tool. Zip, output name, and the input directory. Since we are dealing with a directory, we have to use the recursive flag. Now to extract a zip file, we can use the unzip command. Unzip and the zip file name. Since we have a directory with the same name, it asks whether to replace it or not. Let's not replace it. Instead, we can save the extracted directory in a new one. Unzip, zip file name, -d, and then the extraction directory. This extracts the contents into a new directory. Let's use the gzip command. The gzip command is useful to compress individual files and it doesn't work on directories. This throws an error. Let's compress the files within extracted dir's subdirectory. This compresses all the files. If you have noticed, the original files were replaced with compressed files, which means it does in-place compression. To keep the original files, we have to add the k flag. Let's try it on the split dir itself. We will also use the v flag to make it verbose. Now we have both the compressed and uncompressed files. To uncompress, we have to use the d flag. That's gzip. When we are dealing with large files, it might be beneficial to perform the process using multiple threads. By default, gzip doesn't have that option. We can use another tool called pigz, which can perform the gzip tasks on multiple threads. You can install it with dnf and apt. Now let's look at using the tar command. This can be used to do the archiving alone, which generates tar files, or combining the compression task to generate the tar gz or tar bz2 file. If we check the help output, we can see that it supports many compression formats. So let's start by archiving the directories. Before that, let me delete the previously generated gz files in the split dir. Now to perform the archiving, we may have to use a combination of flags. C for compression, V for verbose, F for file. tar-cvf, output file name, and the input directory. If we list the contents, we can see that tar file takes more space than a zip file because we have just created an archive, not a compressed file. To actually perform the compression, we can add the z flag to get a gz file. To extract files from tar or tar gz files, we have to use the x flag instead of the c flag. Since it overrides the existing files, let's make a new directory and navigate into it. Similarly, for the tar.gz file, we can do like this. That's a wrap on file and directory management. Now let's look at a few commands that will help us retrieve information regarding our system as well as installed and running packages. At some later stage, we will be running our programs parallelly using multiple CPU cores. For that, first we need to know how many cores and threads the machine has. This can be achieved by retrieving the CPU information using the lscpu command. This prints out CPU information. So my system has 12 CPU threads. Similarly, we can see the PCI devices on a system using the lspci command. We can pipe this to other commands for extra functionality. Say we are interested in getting information about the NVIDIA cards, we can pipe grep iflag and then NVIDIA. Further, we can get RAM details using lsmem and disk block details using lsblk. We can also check the amount of used and free RAM by using the free command. Similarly, the disk usage can be obtained by using the df command. Another really useful command is the du command. This prints the space occupied by various items in the current directory, but make sure to add how many levels it has to display with the d flag. Let's also add the h flag to get the output in human readable format. While we are running jobs, we may want to see how much of the resources are being used by various processes. We can have an overview of this using the top command. It shows dynamic system stats like memory used, swap used, top resource consuming processes, etc. We can exit from it by pressing Q. For a better visualization, we can use the htop or bpytop programs. We can install these with dnf and apt. I prefer to keep one of these programs open in a separate window to have a quick overview of the resources. As you can see, each of the processes has its own ID called PID. We can use this ID to terminate the process with the kill command. Let's open a Firefox window, note the PID, and then kill it. Or we can use the process name with the pkill command. Right. Now let's see which kernel version we are currently running with uname -r flag. Uname all flag prints out the complete information. To see the current user's name, we can type whoami. It may not be intriguing to use this as such because you know who you are, but it is useful when writing scripts. Similarly, to see which users are logged in currently, we can use the who command. Another useful command is which. The which command gives us the path of the inquired program, which bash. So this is particularly useful when we have multiple installations of a program at different locations. For example, we can install different versions of Python in different environments. We will see that while dealing with Conda or Mamba. In this case, the which command prints out the location of currently running Python. And we can also print out all the available locations with the -a flag. As of now, I have only one Python installation. Alright, that should cover the basics of bash. In the next video, we will look at bashrc and bash aliases and make some basic bash scripts.